Okay, let's take a look at part W for -6. For the interval -6 is less than or equal to x, less than or equal to -2. F prime of x is 1/4 times x plus 4 cubed. If f of -2 is 0, find the minimum value of f of x on that interval. Now, notice right here, this says the interval from -6 to -2. Recall if we go back up to the graph, we were giving nothing to the left of -2. So now what they're saying is, yes, there is something going on between -6 and -2, and here it is. Also notice in the question, it talks about what's going on between -6 and +2. All right, so right here, what's the minimum on that interval? So that means we're going to be using this piece, and we'll be using the graph from -2 to +2. So we're going to have to kind of split this up into two pieces. So find the minimum value of f of x on -6 to 2. Well, remember, minimum values occur at critical numbers. So that's where f double or f prime of x is 0 or undefined. So f prime of x is 0 on this interval when, and we're given f prime, 1/4 x plus 4 cubed is 0. Multiply both sides by 4. Take the cube root of both sides, and we get x equals -4. Now, if you're quick enough and you're with it, you could look at this right here and say, well, wait a minute, 1/4 x plus 4 cubed would be 0. Well, that would have to happen if this entire inside piece came out to be 0. And that's only going to happen if this is -4. So you could jump to the end. More than likely, though, you'll end up solving it algebraically. That's fine. F prime of x is 0 on -2 to 2. And there we can just go by looking at it if we look at the graph, it happens at x equals 0. All right. So now what we need to do is we need to go ahead and we're going to do what we call the extreme value theorem. That is that there must be an extreme, maximum or minimum, on a closed interval from -6 to 2. And that extreme must happen at a critical number, so -4 and 0, or one of the endpoints. So what we need to do now is find f of those 4 values. So how do we do that? We need to first of all find out what f is. So we're going to take the integral of f prime of x. So the integral from 1/4 of x plus 4 cubed is, now because this u here has a derivative of 1, this is very nice. I'm going to throw a dx in here. So we just get 1/4 x plus 4 to the 4th over 16 plus a constant. We know that -2 is on this interval. So if f of -2 is 0, that means 1/4 times -2 plus 4 to the 4th. I need to go back here. This 16 here should actually be 4. Apologize. Plus c equals 0. So -2 plus 4 is 2. 2 to the 4th is 16. 16 divided by 4 is 4. 1/4 of 4 is 1. So we get 1 plus c is 0. So c is -1. So on that interval from -6 to -2, f of x is 1/16. The 4 times 4 is 16. So that's why I made that mistake earlier. X plus 4 to the 4th minus 1. All right, So let's go ahead and let's create a little table down here. And we're going to start at -6. And f of -6, well, we just plug in -6 into our function here. So 1/16, -6 plus 4 to the fourth, minus 1. So -6 plus 4 is -2 to the fourth is 16. 1/16 of 16 is 1, minus 1, we get 0. -4, again, we're still on that interval, so we can go 1/16, -4 plus 4 to the fourth, minus 1. -4 plus 4 is 0 to the fourth is 0. Times 1/16 is 0, minus 1 is -1. It's 0. Now, we're outside of this interval, so this function is irrelevant right now. Now we have to refer to the graph. How do I find f? The graph is the graph of f prime, so we are going to find the graph of f by taking the integral from -2, which is a left-hand edge of the interval, up to 0 of f prime of x dx. So if we go to our graph from -2 to 0, we're going to find the area, remember, by taking this entire square, which has an area of 4, excuse me, and subtracting 1/4 of the area, a quarter of a circle, and that'll give us this area here. We've actually done it earlier, but I'll show you how to do it again. So at 0, it's going to be 4, which is the area of that entire square, minus 1/4 of pi times the radius squared. Radius being 2. 2 squared is 4 times 1/4 is 1. That leaves me a pi here, so I get 4 minus pi. So right now, and we still have one more point to figure out, that's a 2. Right now, the minimum is sitting here at -4 because 0 is bigger than -1 and 4 minus pi is still positive. So let's go ahead and find the integral from -2 to 2 of f prime of x dx. Now, remember how I said earlier on in this problem, we had already evaluated the integral from -2 to 0. So I forget exactly which part it is, but be very aware that when you do these FRQ questions, quite often they use the answers from previous parts. So if you ever have to do an integral later on in part D or something like that, always look back to see if you did it in an earlier part. We also did the integral from -2 to 2. Okay, I'll do it anyway. That we did on Wednesday in class. That's going to be, if we go back here from -2 to 2, that's this box, this rectangle here, which has an area of 8 minus the area of the semicircle. So we're going to go 8 minus 1/2 pi times r squared. Radius is 2, so 2 squared is 4, divided by 2 is 2. So I end up getting 8 minus 2 pi. 2 times pi is not even 7. It's 6.28-ish something, so this is still positive. So what's the minimum value? The minimum value is -1 at, and if you want to put it, you can say that happens at x equals -4. Okay, like I said, that's a long question, but I would say if this were an FRQ question, that'd probably be 2 to 3 parts of the FRQ question, because both integrals and things like that. So, all right, I'm going to go again and pause it here, and then we will pick up on part X in the next question, in the next video.